An angle is the union of two rays. So if you recall, a ray had an endpoint and an arrow. And then if I union two of these, meaning put them together, remember your set notation and your set vocabulary, I just formed an angle. And this is how we mark the angle. We put a line in there. And so they are united there, or union at there, what we call the segment's endpoint. The vertex is this point right here. We'll call it A. So the vertex is that common endpoint that they shared. The side would be each ray. The sides consist of the ray. Then we have an interior and an exterior to this. The interior region is inside, so that's the interior or the inside of the angle, and the exterior would be the outside, so it would be all this on the outside. So that's what it means when we have an interior and an exterior. So a plane then, if you think about it, is three disjoint sets. If we look at this angle in a plane, we have three disjoint sets. We have the angle, which is different than the interior, which is then different than the exterior. In other words, there's no overlap. They are disjoint. The angle itself, so we have the yellow, we have the blue, and then we have that angle. So we're going to move down to naming angles, and we can name angles based upon their vertex and the angle with 3 points. So when we look at an angle here, I could call this angle A. Notice I'm using capital letters. Or if I had some points on here, we could name it with those 3 points. But when you name with 3 points, the vertex is the middle point. So BAC, that's my angle, and that's usually how we denote that we're measuring an angle or looking at an angle. Or angle CAB. Just like we said, this vertex right here has to land in the middle if you're going to name it with 3 points. We measure angles with that half circle thing, and that's called a protractor. We did that last section when we looked at our circle and looked at the color of M&Ms. And the units that we measure with, we measure in degrees. And then degrees can actually be split into minutes and even smaller into seconds. And we have some common benchmark angles that we use a lot in geometry. That would be a 30 degrees, a 60 degrees, a 90 degrees, and then a 45-degree angle. I hope it's obvious why we'd use a 90 degree. The 30 and 60 come from some special triangles that we'll be looking at later on.